jack jumper and the load buster. What types of situations are we going to have to use the load buster in? Anybody got any ideas on that one?
When you're trying to open a switch under high load.
That's true. How are you going to determine if it's got high load on it or not?
Measure it.
Yeah, you can put an amp meter around the high side riser, the low side riser to wherever it goes. If it goes to a tap or to a transformer, put your amp meter around it. You can actually put it right around the fuse barrel if you want to, and just get an amp reading on it. And I can tell you, if you do something like that, typically it's just going to rise and fall in a range. It's not going to be large. So if you've got a 50 kVA transformer, you know, like might be 7 amps and 6 amps, go down to 5 and may go up to 8, and it's just going to rock up and down as people turn things on and off in their homes. There's Noah. Now there's a couple of different techniques that you probably are going to see linemen do out there in the world that don't have a load buster, that are effective but not as effective as a load buster. So we're going to watch the video first, and then we'll go to those others. Everybody able to see my screen?
Yep.
Okay.
Mm-hmm.
This video is intended to be used in conjunction with the written instructions that came with your product. S&C Instruction Sheet 811-505. You can download these instructions at snc.com. The Load Buster load break tool is used to switch equipment that operates at high voltage. Failure to observe the precautions below will result in serious personal injury or death. Some of these precautions may differ from your company's operating procedures and rules. Where a discrepancy exists, follow your company's operating procedures and rules. The Load Buster tool must only be used for specific switching applications that are within the ratings of the tool selected. The Load Buster tool ratings are listed on a ratings label attached to the chassis of the tool.
Okay, so you got to watch out for 2 ratings on the tool. One of them is the maximum voltage that's allowed for the tool to be used on, and typically they come in 20 kV and 40 kV tools. So you're able to use the tool up to 20 kV. Excuse me. You're able to use the tool up to 20 kV or up to 40 kV, and there's also an amperage value. They have 2 different units, and the cost between those 2 units is substantial. There's a 200 amp and a 300 amp tool. So if you take a reading with a amp meter and it says 310 amps, can I use a 200 amp load buster tool on it?
No.
No, obviously not. It's going to blow up the tool. So definitely read the ratings on the tool before you use it.
Prior to using the Load Buster tool, be sure you have read and you understand the application notes and operating considerations sections of the written instructions, because certain application restrictions apply, especially with regard to single pole switching of ungrounded primary 3-phase transformers or banks of single-phase transformers. Load Buster, the S&C load break tool, is the original lightweight, easy-to-use, portable load break tool. It brings load switching capability through 34.5 kV and 600 amperes nominal, 900 amperes maximum to your overhead distribution system.
Okay, so he's got actually a 34 kV, 600 amp nominal 900 amp maximum tool. So obviously we know what voltage we can use it on. That's a weird fuse barrel configuration right there that you're looking at. What do they mean by 600 amp nominal, 900 amp maximum?
Is that up to or around kind of mean thing?
When you say kind of that nominal situation, I mean, the tool's not going to last forever, right? It's load busting. If you're having to do load busting all the time, if you go up to 600 amps and you're using it regularly at 600 amps or below, you can use the tool for a good while. It will break 900 amps when needed, but you're definitely going to be starting to degrade the tool. And to be honest with you, there's no really good way to test it without taking it apart and seeing the load break mechanism inside, see if it's arcing or melting or whatnot. So you're out there in the field and, you're using this thing regularly and you're breaking 50, 100, 200. I mean, the thing will last pretty much forever. You start breaking 900 amp loads or around that area, 900, 800 amp loads, you might want to take it apart and inspect it every so often.
The load buster tool works by providing a current path between the upper contact and pull ring of a hook-equipped distribution device. When operated, the load current is diverted through the load buster tool and interrupted within.
Okay, so that was kind of quick in the way they showed it. And S&C, which obviously makes switches out there in the world, also makes the tool. Almost all of your switches right now, I know you've seen our switches, have these little galvanized horns that stick out at the top of the switch right here. You hook that one part of the load buster here to the top of the switch, then you hook this assembly into the eye, and he went in fast motion here. The barrel opens and you still have current flow from here to here to here. As the switch stick comes down, load is busted in here and it doesn't flow from this point anymore. The top is still hot. It's because of the high side riser on top. So that was extremely fast. I would suspect they're going to slow it down here.
When operated, the load current is diverted through the load buster tool.
Is there any reason why you guys kind of wonder why they open it so fast?
So it doesn't arc.
I got two at one time. I think I heard Elijah. Go ahead, Elijah.
So it doesn't arc.
Okay, it's not supposed to arc anyway because we're using a load buster tool. What was the other answer?
I said the same thing.
Okay, you want this, these things are meant to be operated. Load busting's happening in this tube right here. And actually in some cases, there's an exhaust system here at the bottom. You'll see a little bit of smoke and fire fly out of the bottom because it's busted a large amount of load. You want to operate that thing like I've told you guys, the way you put on elbows and pull off elbows in a pad mount transformer. Smooth and quick, so that load busting operation goes on in here, does what it's really supposed to meant to do, break load quickly. If you kind of lollygag around about it, it's going to start arcing in this tube and the load's not going to bust.
Ring of a hook-equipped distribution device. When operated, the load current is diverted through the load buster tool and interrupted within. We will demonstrate operation on an SMD-20 power fuse, but the procedure is equally applicable to fuse cutouts.
What size fuse is it?
200 amp.
It's a 200 amp fuse, yeah. Now this is not a normal one that you can replace in a fuse barrel. You'll notice this is completely different. This is actually a switchgear fuse.
Disconnects, power fuses, and fuse limiters with an attachment hook at the upper end of the device and a pull ring on the device's switchblade or fuse tube. For usual operating conditions, the load buster tool is fastened to a universal pole not less than 6 feet, 183 centimeters long, with the frame of the tool in line with the pole.
Okay, he says something specific there, and that's a safety thing that's going on. What do you say the length of the stick has to be at least minimum?
6 feet.
Yeah,
That's
don't worry about the
amount.
centimeters. We all know the 6 foot situation. They do actually make sticks that can go in your bucket truck that are 3 and 4 feet long. It's not meant to be used with this tool right here. You got to use a 6 foot or longer switch stick. So they come in 6, 8, and 10 foot sticks. This thing will not work on an extension stick, guys. It's just way too heavy.
Before operating, check for proper resetting of the load buster tool by extending the tool about 3 inches by hand. Throughout this travel, an increasing spring resistance should be felt. When operating from a bucket truck, stay at least 5 feet, 1.5 meters, below the device and in front of the fuse cutouts, fuse limiters, and vertically mounted disconnects and fuses. When disconnects are mounted inverted, approach the attachment hook from the hinge end, staying well below the device to be opened, so excessive horizontal force is not exerted on the insulator. The load buster tool has an anchor, which attaches to the attachment hook of the operating device, and a pull ring hook, which attaches to the device's pull ring. Step 1. Reach across in front of the SMD20 fuse mounting with the load buster tool and hook the anchor on the far side of the SMD20 mounting. The load buster tool should never be attached with its anchor hooked on the closest side of the fuse cutout or other device. Attaching the tool in this manner would not only obscure the operator's line of vision, but it could also result in placing a bending stress on the tool and make disengagement difficult. Step 2. Swing the load buster tool toward the SMU20 fuse itself and pass the load buster tool pull ring hook through the pull ring on the fuse. The pull ring latch will deflect and, upon complete entry of the pull ring, will spring back, locking the load buster tool to the pull ring.
Okay. So right now, the way it has it, I still have current flow that's going through the fuse. As soon as I start to make the pull motion on this stick, I'm going to have current. This is going to start to open and clear the top of the switch, but I'm still going to have current flow from here to here to here until I make the full motion and break load inside the tube.
The load buster tool is now connected across the upper contact of the SMD20 power fuse. Step 3. To open the circuit, operate the load buster tool with a firm, steady pull until it is extended to its maximum length. Avoid jerking and hesitating. The resetting latch will keep it open. Generally, there will be no indication of circuit interruption, but minor arcing may be noted at the pull ring hook and at the anchor, particularly when interrupting load currents approach the rating of the tool.
Okay, so you hear what he said? What minor arcing? You might see it spitting a little bit and spitting a little fire out of this area and this area. And also it's got exhaust ports here and here where it breaks the load, and it's going to expel all the gases that come off that load break. So just be ready for it. Now, if you're breaking a small load with it, that's not going to happen. But if you're reaching towards the rating of the tool, 600 amps and that nature for this one, it's going to make a little noise. It's going to make a little bit of fire up here.
The only sound will be that of the load buster tool tripping. Step 4. To detach the load buster tool after circuit interruption, first raise it slightly and disengage the anchor.
Okay, this is of vital importance. And it gets touchy. You have to watch what you're doing right here.
Step 4. To detach the load buster tool after circuit interruption, first raise it slightly and disengage the.
Okay, so he pushes it up, and I got to stress the word slightly. He pushes it up to get this hook off that hook of the switch. All right, and then he's rolling the stick in his hands clockwise. Excuse me. He's rolling it clockwise, and this snaps out of the hook. If you push this too far up, what's going to happen?
It's going to jump across.
You pretty much got to make contact. Just don't make contact again. If you push this too far up to get this off the hook right here, you're going to reinitiate contact with the top, and then you're going to be stuck. Then you're just going to have to let that fuse barrel roll open, and the load will be happening. The load you just busted will be reinitiated right here at the top of the switch, and you won't be able to put it out. You talk about a little bit. Does voltage jump?
Yeah.
Yes.
No. You pretty much got to make, if you're up in the 230, 500 kV transmission ranges, I would say if you get in close proximity, you might be about a foot away or half a foot away, and you're going to get a voltage jump just because of the electrostatic field that's on those conductors. Down at these voltages, no. You pretty much got to make contact for electricity to flow.
Anchor from the attachment hook. When the loadbuster tool is raised, the open gap distance is reduced. Careless manipulation could decrease the open gap to the point where flashover will occur. Next, bring the fuse toward its fully open position. Remove the loadbuster tool from the pull ring by turning the pole. This will deflect the pull ring latch to release the pull ring. On devices where the fuse will drop fully open by gravity, it may be preferred to remove the loadbuster tool by rolling it off, both the attachment hook and pull ring, at the same time, merely by twisting the pole after the loadbuster tool has been tripped and fully extended.
So what he has done right there, instead of pushing up and off the hook, he just rolled right where it's sitting at, which is perfectly okay. Just rolled it right out clockwise.
Pole after the loadbuster tool has been tripped and fully extended. To perform this operation easily and smoothly, always roll the loadbuster tool so it rotates in an upward direction. Step 5. To reset the loadbuster tool for the next operation, extend the tool slightly and lift the resetting latch with your thumb. With the latch up, press down on the inner tube assembly until the tool is closed completely so the trigger can reset itself. When reset properly, the orange paint on the inner tube assembly will no longer be visible. Check for proper resetting by extending the tool about 3 inches. An increasing spring resistance should be felt. The method of operation works equally well with cutouts, loadbuster disconnect switches, and most other devices with a hook and pull ring. Loadbuster tools manufactured after March 2003 are equipped with a non-resettable operation counter that lets you monitor the use of your tools to make more informed decisions with regard to inspection and maintenance. The operation counter is built into the Loadbuster tool's silencer and can be easily added to existing tools. If you have any questions about Loadbuster tool, visit our website at snc.com.
Okay, any questions there? Pretty cool tool, isn't it?
Yeah. Does that counter? That's only counts the times you operate it, right? That doesn't like measure the amps you use it on.
You're correct. Yeah, it only counts the amount of times that you've used it open. Now, it's not, like you said, it's not going to measure how much load has gone through it and how many different times you've broken high loads with it. It's just going to use the counter to show you how many times you've opened it. Even if you tested it and accidentally opened it, it's going to count that one too. There in the manual, it's going to show you the recommended amount of opens that you got on it. I think around some of these, if you use them in the right load conditions, not really high loads, they'll go to 2,000, 3,000 operations. It is a very, of course, always expensive piece of equipment. All right, one more here. Okay. This thing is also pretty cool here, and I'll tell you the reason why they use it sometimes in utilities. Sometimes you'll have to go out in utilities and do what they call fuse coordination. And we talked about fuse coordination before a little bit with Professor Bermelin. Sometimes your fuses, especially when there's a season change, or if you've added more load onto a circuit, especially a tap line, you're going to have to upgrade, or in some cases downgrade fuses. Well, there's a way to do that without having to open the switch, and it's called the jack jumper cutout bypass tool. Okay, so in these cases right here, you got to watch some safety things going on. This is the jack jumper right here, and we use them a lot on our system. Your electrical flow now is from the high side riser through the switch, through the jack jumper, and this is not a bolted connection, it's just a spring-loaded connection through the low side riser to wherever it's going. So power current flow has not been interrupted. The thing you got to look out for here, and I've seen employees do it, is they'll open the fuse up and then go up there with their rubber gloves, and they'll do what? Remember, we're changing. Yeah, we're changing out the fuse. The fuse barrel is hot also, all the way down to the end cap, because the bottom of the switch is too. So make sure that when you open the switch, and before that you open the switch, that you have anything down in this area right here is going to be in the clear. You're not going to make contact with the fuse barrel and the fuse barrel cap with anything down in this area. We tried not to use these too much in underground, and you can see why. The underground terminator usually comes up in this area, terminates in here, and then the wire sits right in this area. And remember, the jacket that's on the outside of the cable, is it insulated or not? On underground primary cable. The outer jacket?
Insulated.
It is not insulated. That's just polyethylene. It's just a polyethylene protective cover, and they're trying to save money on conductor there. Right underneath that is the ground. So these fuse barrels, and this one didn't travel too far, can swing backwards a little bit. The eye of the fuse barrel down here at the bottom and the cap will make contact with the ground that's on the underground primary, and you're going to have a phase to ground fault. So be careful with these. Make sure that you have plenty of clearance at the bottom before you open up the fuse barrel. Okay, as with everything out there in the world, there's two kinds of ratings on this. I can read one, can't read the other. One is what? Voltage, and the other?
Amperage.
Amperage, yeah. Go to the specified, and not above the specified voltage that's written on the jack jumper. This one is 15 kV. The writing's too small on it for me to see right here, and don't go above the rating of the amperage value that's on it. Always read your equipment before you use it. Has anybody seen this tool right here? Professor V's used it a couple times.
Yeah, I tried to get him to let me use it when I was on the switch on the test.
Yeah, it's a cheater tool. You'll be using it out there in the field. And the reason why I don't let you use it on my field is because when you go to do that skill set test with anybody, they're not going to use these guys. They're going to make you do it the hard way. So that's why I made you guys do it the hard way. Okay, any questions on those two videos? All right, with none. It's 9:32. Let's take about 10 and we'll come back and we'll get started on the other stuff. So let's say about 9:45, 13 minutes. Yeah, about 2 more minutes left and get started back. Dogs over here sound asleep. Okay, we're at 9:45. Let's go ahead and get started back. I'm sharing a screen over here, and we're going to be talking about doing load transfers between substations on a feeder circuit. And it's not really typical, something you're going to be doing every day, but some systems, and I know Santee Cooper did it often, seasonally, they'll move open points around and try to balance out load on different circuits and different breakers. So they're evenly distributing load between substations and breakers. And they'll move open points and close other ones to be able to balance that load out. And also during the course of switching, if you need to get line clearances, which we've talked about before, you'll have to do these in situations. I'll let you guys know, not all systems have SCADA. Not all companies have SCADA. So it's good to know these steps. And like I said before, typically you're going to have a line technician A with you that's going to be operating the radio, and you're going to be operating the stick, opening and closing switches. So it's best that you know that procedurally everything has gone correct before you open or close the switch. So I've got on the diagram right here on the left-hand side, I'm just using them for examples. I'm at Horry Georgetown Technical College. I'm at a substation. We'll call it sub 1. Right here, and I'm using breaker A out of that substation, and off the breaker I've got 3 regulators, and you'll see right through here my feeder circuit. Now this is drawn out simplistic. Of course we know feeder circuits don't go in a straight line, and they also, feeders can branch off in multiple directions. And I'll use substation 2 over here. It's in Carolina Forest, and the breaker that's in that substation that we're going to be using is called breaker C. And then we have our line regulators. All right, procedurally, and I'll type this out on Notepad for you also, the breakers and the regulators before we close a switch have to be what they call set up. All right, you cannot put or move an open point in a system without first closing a switch. The objective here is not to have any customers without power while we do this. So on a feeder system, you must close open point before making a new open point. Okay, that's critical if you want to maintain power on your feeder circuit. If you first open and then close the other one, you're going to have a line section between 2 opens, and all those customers are going to be dropped. You don't want that to happen on your feeder system. So first, you're going to get your field switch in order, and the dispatchers are going to go through a process of what they call setting the breakers up. All right, both breakers must be placed on, and they'll call it this because you're not getting a hotline work permit, non-automatic. What does non-automatic mean?
Means it's going to be manual reclose.
That's one part of it. Are we going to get a breaker? What kind of breaker operation are we going to get if we have a problem?
Instantaneous?
Instantaneous only. When we say non-automatic, it's not going to go through its normal automatic operations. Essentially, the dispatchers have a hotline work permit. Okay? You don't. They do. All right, so we'll go back to our drawing right here. So, and I'll put them in the notepad too. So breaker A, equals non-automatic. Okay, you'll have to set up both breakers in the same fashion. Breaker C, and they'll specify the substation on the radio. Non-automatic. How are they doing this? What system are they using?
SCADA.
SCADA. Yeah, they're doing this all by SCADA. They have to do verbal confirmation over the radio. They're telling you this over the radio, but they're doing it all by SCADA, and you're following steps on a form in the process that's going on. So you're just sitting there in the truck listening. Okay. The next step, and there'll be a little bit of description behind this one. Block, ground, relay, breaker A. Okay, and I'll do the next step because it's the same thing. Block, ground, relay, excuse me, my spelling. Relay, breaker, C. And they'll specify the substation when they have that comment going on right there, or that conversation going in over there. Why do we block the ground relay in both breakers? Now, this is kind of technical, so think about it a little bit. What do I mean by blocking the relay to start with?
Making sure it won't reclose, or
That's not a reclosing relay. That's the ground relay. You're on the right track. It's just simply turning it off. Okay? Don't use. Go down to the next one. Turn it off. Don't use. But there's a reason why we don't want the ground relay to recognize anything. Anybody got any ideas on that? Okay, let's discuss it here. When we open or close, does everybody remember what a GOAB is? What's a GOAB? Okay, we'll go back a little bit then. S and C GOAB. Okay, a GOAB is what they considered, and you'll have to listen to some of the conversations out there. Some people say it's a ground operated air brake switch or a gang operated air brake switch. They come in many forms and fashions, as you can see through the pictures that are going on through here. But a man stands on the ground. You see this one right here. It's got the switch. This goes from an overhead feeder to an underground feeder. It's got the switch right here for all three phases. These are open at this time. And then you can stand on the ground and open and close the switch from the ground. I can see by my photograph here, it does have load brake capabilities. It might be a little bit small for you guys out there. All right, so that's a GOAB. Now, when you stand on the ground and open and close it, do you think the timing on this is exact for all three switches? The timing, the open or the close?
Probably not.
So
Probably not. And I mean, we're looking at, when I say timing wise, how many cycles per second? 60.
60.
Yeah. So we're looking at 1/60th of a second. Something could go wrong in timing, especially when you start getting to switches of this nature that are much larger and bigger. Not all three are going to open, and not all three are going to close at the exact same time. All right, so when that happens, especially on the open, if two phases open and one phase is just a little bit behind in the schedule, let's go ahead and put this in another frame. If two open or one's open and two are just, we're talking milliseconds here behind, what happens with the load on my circuit? Two are making contact, one is not. Will I have load? Say, we'll use this for a scenario. Will I have, if this one's closed, will I have load traveling through this one? Closed.
Yes.
Okay. Say this one's closed. Will I have load traveling through this one?
Yes.
Okay. Say this one just started to open. It's a load break switch. Will I have load traveling through this one?
No.
Okay. We could put some numbers to it right here. 300 amps flowing, 300 amps flowing. This one's partially open, 0 amps flowing. Is that a good condition for my feeder circuit to be in? 300, 300, 0.
No.
No. What do we call that out there in the world? Anybody remember? There's a term for it. Load imbalance, remember? This actually even happens in secondary too, when you don't have one phase of secondary that has the correct amount of load on it. Where or what conductor takes that load imbalance? If you have load imbalance on a circuit, it flows on which conductor? You guys are slow today.
Neutral.
Yeah, there you go. Flows on the neutral. Okay, it's trying to shed that load that's imbalanced to the neutral, and the neutral is grounded, correct? Okay.
Yep.
Yep, the neutral is grounded, N-E-T-R-A-L. All right, so in the situation where I'm opening this switch right here, I've got 300 here, 300 here, and 0 here, right, where it should be. That load imbalance, because I'm missing it, is flowing on the neutral. The ground relay in the substation is going to say, I've got amperage on the neutral. And what's it going to do to the breaker?
A trip.
It's going to trip the breaker. There you go. So that's the, I know it's kind of long in the explanation right here. While you're operating switches, open and closing any kind of switch, either a GoApp switch that you're looking at right here, or regular just static disconnect that you have to open up one at a time. Of course, that's going to take more time. Every time I go to the open procedure, there's going to be load imbalance. Load imbalance is going to flow on the neutral, and the neutral is grounded on these systems that we're talking about. The ground relay is going to detect it. It's going to open the breaker. Do we want that to happen?
No, because then you've lost all the customers anyway.
Yeah, then you've lost the customers on both circuits. Remember, you were trying to tie two circuits together. So you've lost the customers on both circuits. So in the procedure of switching while we're moving our open point, I block the ground relay. I don't want it to recognize that load imbalance that's going to be going on during the course of switching. So that's the reason why we're doing it right here. Okay, next step. In order for me to get both breaker A and breaker C at these substations to what they call tie together. And this goes back to the days that we talked about the higher the voltage, the lower the what?
Amperage.
Amperage, right? And the lower the voltage, the higher the amperage. What you'll have to do is match the voltages between breaker A and breaker C. How can we match voltages at both substations?
With the regulators.
Right, the regulators at both substations have to be matched so they match each other. And it's down to a pretty precise within a volt range. Now, luckily out there, the dispatchers, the information that they're getting back from the regulators is not at the primary voltage, it's at the secondary voltage. And usually it's right around, 120. That's what we want on our system. So what we'll have to do in the procedure to be able to close this switch to start is match regulators on breaker A, and we'll say, and it doesn't have to be exactly 120. It could be between the full range that we have, 126 and 114, as long as it matches the other station. So we'll say A phase 123, B phase 123, and C phase 123. So that's at breaker A at the substation. What do the voltages need to be at breaker C at the other substation?
123.
Exactly. Exactly. Match breaker C regulators A phase 1, 2, 3, B phase 1, 2, 3, C phase 1, 2, 3. Okay. So now the voltages at both breaker C regulators. So now the voltages at both substations are, and it's not going to be exact, like I said, and you want to kind of keep it within a volt range, are both matched to each other. If you don't have, and this is going to be catastrophic, if you don't have the regulators matched at either substation and you close the switch, one is going to go into what they call reverse power flow. If my voltage is higher here and my amperage is lower, and my voltage is lower here and my amperage is higher, this substation will say, well, my voltage is higher. I'm going to go ahead and try to feed through here. I'm going to try to compensate for the entire circuit instead of sharing it with the other one. And really, actually, there have been some cases where the breaker has gone into alarm and you're actually backfeeding into the transmission circuit. Because from here, we go to bus, we go to low side switch, we go to transformer, and you're actually going to start trying to backfeed the transmission line through a substation breaker. Now there's preventative situations in here, and you'll see inside a breaker, they've got a setting for reverse power flow. Once it recognizes that, it's going to lock out both breakers. So you're not getting into that situation. But it is essential that the regulators and the voltages are matched between the two substations. Okay, now we're finally in shape to do what? Close.
Process.
Okay. Now you're in shape. You can go ahead and close your open point. Open, new, open point. Sorry about that. Should have been a new line. Open, new, open point. Just go ahead and do it on the map here. All right. So I wanted to move this open point right here to here for any specific reason we had in our system. Let's get rid of this one. I closed my switch there. I open my switch here. All right, good to go. After this is complete, and that's all there is to do on this feeder circuit between the two substations, I just return everything back to normal. So Let's go put those steps down right here. All right. Return regulators. Sub A back to normal. Return regulators. Sub C back to normal. Return, I know this is a lot of steps. Let's see. Restore ground relay sub A. Restore ground relay sub C. Sub A back to automatic. Sub C back to automatic. You can see, and there's some points here that is going on as far as the communications and conversation that you're having with dispatch. How many steps do I hear? Okay, that's one, my place. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This should have been 2 steps in the conversation. So actually 15 steps to move one open point. You're going to also, and we'll do it out here at the field when we get the field rebuilt back in the square, we're going to get on Zello and we're going to have the actual radio, like a phone conversation on a walkie-talkie, to where you guys are going to do this. You're going to, 1, get a line clearance, and 2, create a new open point. So you guys will know the radio procedures out there in the field. All right. Before we take a break here, simplistically, in your conversations that you have from dispatch, Whittington, you probably be good on this because you've worked in what? First responder before, right?
Yes, sir.
All right, you get a command from dispatch given. What do you need to do?
You need to verbally confirm the command.
Repeat the command. Okay. And then the dispatchers are going to confirm. All right. That's how pretty much the process goes in the full scope of what's going on here. So I'll give one example. I'll be the dispatcher and the person that's talking. 260, I'm ready for you to close the open point at 1, 2, 3, 4, 5. My answer back would be, I understand you're ready for me to close at pole 1, 2, 3, 4, 5. The dispatcher's going to say that is correct. I also have to call back and tell him when it is closed. I'm going to say at this time, pole number 1, 2, 3, 4, 5 is closed. The dispatcher has to repeat back to me, I understand the switches are closed at pole number 1, 2, 3, 4, 5, and I'm going to have to say that's correct. What was that? 6 different directions to be able to close one switch. All right. Okay, it's what? Time flies when you're having fun. It's 10:10 right now. Let's come back at 10:20. It's 10:08. Let's come back at 10:20. Let's take a break. So this is a diagram of the 2 feeders I had before, breaker A on the left and breaker C on the right. This is going to happen usually, well, not usually, almost all the time, unless you've got a poor company out there, on the switch install. So every time I install a new ground operated air brake switch or a new set of disconnect switches to create an open point on a feeder or a closed point if I need it later on. Something's got to happen to make sure that everybody that uses it afterwards is going to be okay as far as phasing is concerned. Now, back to the diagram here. What would happen if I close this switch, erase that, and change this to B, and change that to A. And the configuration of feeder circuits as far as the phasing is concerned can change because I need to turn corners. I need to, go underground. Whatever I need to do on the entirety of the circuit may change the phase location as far as that's concerned in multiple instances. So this can happen regularly. What would happen in this case right now if I've got breaker C over here and breaker A, and I'm already set up and through the process of switching? What would happen if I close the switch on the top, the B and A circuit, B and A phases?
I'm gonna trip the breakers, isn't it?
It's going to trip both the breakers out. That essentially what you're doing right there is you're creating a phase-to-phase fault.
That happen often?
No, and we're going to go back and tell you why in the process. It's only happened to me once, and I'll give you the backstory behind it of what happened afterwards too. It was it was very expensive. All right, so on the initial switch install, when the crew comes to install a new switch at a location, what they're going to have to do is phasing. So down here at the bottom, feeder switch phasing is done when the switch is installed, and that is mandatory. So actually, when the work request comes out, a field switching order is going to be coming with it because it has to be recorded at dispatch also. So that's attached to the work request you're going to get. And you're going to use those Hastings phasing sticks across the open point. Remember the video of the two old guys? When they were using the Hastings sticks and they were doing phasing across the switch and they were measuring phases and whatnot?
Yeah.
Yes, sir.
Yeah, all right. Same thing that they were doing. We're going to go into a little, let's see, Control Z. Get rid of this stuff and do a couple different scenarios here for you to know what you're going to see on the sticks. All right, so you've installed your new switch right here. Hopefully in the process, you've already confirmed phases. And to make it simplistic, if I've got a pole, I'm going to draw this from the top down. Here's my pole, and I've got 3 feeder lines coming in this way and 3 this way. All right. In normal operation, before I install my switch, this was like this, right? Here's my cross arm. Okay, so all my phases really were all the same phase to start with. This was A, this was B, and this was C. As soon as I install my switch and dead end this side, dead end this side, and this side, and put my jumpers to the switch, am I worried about phasing?
No.
No.
Okay. Even with that, even though I've got this work request to do it and install a switch at this location, it's going to be mandatory that I have a field switch in order and actually do phasing on it. Now, it's pretty obvious. I'm not going to take a jumper from this side and go over to here, or take a jumper from this side and go over there. That's just not going to happen. I mean, for one thing, it's just not going to work. Okay. But even with that, they still want the radio communication and a confirmed field switch in order that phasing was done. All right, so you run into a situation. I'm going to put a phasing stick, and we'll say this is 7,200 volts. On this side, 7,200 volts. On this side, I put my phasing stick here, and I put my other phasing stick over here. What should the reading be on the Hastings meter?
12,470, right?
Correct. All right.
Which is bad.
Yeah, which is bad. Obviously, I know I cannot close that switch, and we got to back up and find a resolution before we can do any switch closures. Is the same thing gonna, let's see, BC, well, it's gonna happen to all 3 phases now. BCA is going to be down here. This one's going to show wrong, C to B, and this one's A to C. All three are just going to show 12,470. It cannot be closed. I don't know how far back this will erase. Just stop right there and erase some of these. All right, let's see. So let's go ahead and phase here the way it should be. A, B, C. All right, you should not have to do this because this was previously done at the switch location when it was installed. Now, if you've got questions or somebody recommends that you go ahead and phase across this switch just to make sure, maybe it was a very, very old install or something changed on this feeder circuit over here or over here, and they recommend for you to go ahead and do phasing across it. I put a stick here, once again, it's 7,200. This is 7,200. I put a stick here, I put a stick here. What should, open point, what should my voltage reading be?
7,200.
Phase the ground. That'll be 7,200.
Anybody else? Okay. Who said phase to ground?
I did.
Okay. Are we going phase to ground?
No.
Okay. Any other answers here?
If it's open, shouldn't the other side be 0?
There you go. 0. 0 volts or something very close to it. I'm working on the same conductor, A and A. This is 7,200. This is 7,200. This is A. This is A. So there should be no difference in potential between the two voltages right here. The sticks should read 0.
Yeah, that's what I'm saying. Nothing. It'll read nothing because it don't have ground, right?
Right. Well, it doesn't have ground current flow, and you're working on the same conductor. Essentially, with the sticks, and remember it had the cord. Here's your stick, and here's your stick, and it had the cord in between. Right? There's no difference in potential. You're just making continuation of a circuit. This is A, 7,200. This is A, 7,200. It's like taking a voltmeter on a piece of secondary wire, one wire that's hot, and putting both leads on the same wire. What kind of voltage are you going to get?
0.
0. Yeah. Here's my wire. I put 120 volts on it. Okay. I put a lead on this end. It's got 120 volts, and I put a lead on this other end. It's got 120 volts. How many volts am I going to read on the meter? Same wire.
0.
0. There's no difference in potential. I'm not touching the ground with the lead. I'm not touching another phase with the lead. It's just going to read 0. So if you go across the switch with A, 0, you're good. B, 0, good. C, 0, good. This switch you can close. All right, so that is switch phasing. Once again, should have been done. 99% of the time has been done unless it's a real old switch location or something's happened on the circuit where you've had to change things around. And then the recommendations from the dispatcher and the supervisor will be, please go ahead and phase that switch before you close it. And that's the procedure to do it. Just put your Hastings fiberglass sticks across the open point right here, and your voltage reading should be 0. Okay. So is there anything I need to include in the notes here? Use Hastings phasing sticks across open point. Same phase should be 0. Okay. All right. Something we bypassed a little bit here, and I'm going to bounce back a little bit in the discussions that we've had before, and it has to do with having breakers on not automatic. Get back over here. File. New. Don't save. Okay. Who can remember what are the two types of fuse schemes that I can have on a system? Fuse
Saving
saving
and blowing, right?
and fuse blowing. Do you remember what kind of breaker operation you have with each? Fuse saving equals a what?
It was instantaneous,
Instantaneous. So I have
and
an
blowing was
I.
timed.
So I have an I operation here. This one equals a T operation on fuse blowing. All right. There's a procedure you need to follow here, especially in the fuse saving situation. And I'll use that capacitor bank that we had yesterday as an explanation. Anytime we have a hotline work permit, whoops, that's control. We have HLWP on circuit. It must be canceled. CELED before any switch close. All right. This is on, and once again, we're fuse here. So we're not talking about disconnect switches. We're talking about fuse switches or any fuse type situations. The case is going to happen here, and we'll give an example. When we did the capacitor bank, and we went through those steps right there, we opened the fuse cutouts. Say we had a hotline work permit on the circuit. What do we need to do before we close the fuse cutouts in that step?
Cancel the permit.
Cancel the what?
Hotline work permit.
Cancel your hotline work permit. If I install a new transformer and switch on a pole, get it all constructed, everything's done, the last thing I need to do is close the switch. Same situation. I need to cancel my hotline work permit. If I'm working on a tap line, on a feeder, any switch that I need to close and I've completed my work, the only thing I need to do is reclose a fuse. You've got to cancel your hotline work permit, right? Is there any danger in canceling the hotline work permit for the duty that you have to do? All I'm doing is closing a switch and a fuse with a stick.
No.
No, you're all right with that. You're using a stick. You're away from the actual conductors and whatnot, and equipment. So, and you got all your safety gear on, so you're okay as far as that situation is concerned. You're not within approach distances, and you're not working directly on the primary. All right? Why? Why do I have to cancel my hotline work permit before closing any fuse on a fuse saving scheme?
It's going to trip the breaker.
Yeah.
And then it's not going to come back on.
Yeah. Well, you're not really worried about that. It's not going to come back on anyway because you got a what? Hotline work permit.
Yeah.
If you close the fuse and for any reason there's a fault on the circuit, fault on the transformer, for any type of reason that there's a fault on a piece of new equipment or old equipment that you close a fuse on, and you do not give up the hotline work permit, you're going to lock the breaker out because you are in a I operation situation. Switch that around. I've completed my work. I had a hotline work permit. I canceled it. Okay, so now we're back in normal operation. I closed the fuse and the transformer was bad. What's going to happen with the breaker? I do not have a hotline work permit on it. You're going to get a what?
It's gonna-
You're going to get an eye operation, and then what? An immediate reclose. It's back in its normal work. And most of the time, these eye operations are so fast, the customers don't even see it. If I were to maintain that hotline work permit and close the fuse, I'd get an eye operation and I wouldn't get the reclose. Okay, so that is a rule. Put it down here at the bottom. All right.
Well, if there was a problem, it would trip out the breaker anyways, so why would it matter?
Not in non-automatic. I think the description, what you're looking for here, you'd be kind of surprised about it. Where do you live, Wilson?
Conway.
So you're on a Santee Cooper system?
Sure.
I can pretty much guarantee you, and this is because of nature and everything, lightning strikes and whatever. How many times has your power gone off in the past month?
Not at all.
Okay, I bet you it has. I can pretty much guarantee it. And you've probably had, depending on the location, probably about half a dozen eye operations. Never did see it though, did you?
Nope.
It happened so fast in the process, and the breaker was in automatic, that it opened and closed within 3 to 5 cycles. You never even saw it. Didn't even have to reset your clocks or anything like that. Okay. In non-automatic, with a hotline work permit, you're going to get that instantaneous open. The breaker's not going to reclose with a hotline work permit.
And then there's going to be a lot of unhappy people.
You got.
But if there was a fault, though, wouldn't it eventually stay open?
No, it's still going to have the time cycle, buddy. It's still going to blow the fuse.
We're going to go to the time cycle. Okay. And this is the point we're getting to right here. It's going to go, as soon as you have the instantaneous open and reclose, the fuse is going to blow. And you normally, if it's a good fault, are not going to go to timed. You're going to give that time, you're going to give that fuse just enough time to blow before you get to the next timed operation.
Okay, I'm tracking.
The eye target in the eye operation in normal day-to-day, I don't have a hotline work permit, is meant for an eye open, an immediate reclose, a fuse blow, and not go to timed. That's the way your system is designed. Okay, and of course that's going to depend on the fault intensity and the size fuse you're working for, but that's the way you want your system to work. A real fast open close like that, hopefully customers don't even recognize it, fuse blows, and then that just one section of line is out rather than the whole feeder.
Yeah, the whole fuse saving term was messing me up, so I understand now.
Yeah, fuse saving, I can kind of understand. You've saved your system, not the fuse, when you're in the fuse saving scheme.
Yeah.
Okay, you saved. I can see where you see the contradiction in terms right there. Okay, so back to what we were talking about as far as what you guys do in work. When you have a hotline, HLWP, it must be surrendered before closing any fuse on a fuse saving scheme system. All right. Inversely, and this is really going to go as far as what your company policy says to do out here. What about a fuse blowing scheme? I've got a hotline work permit on this circuit. Do I need to do this in a fuse blowing scheme?
No.
Be careful.
So you won't need to.
Be careful. Remember the story I told you about the 34 kV breaker in Myrtle Beach? Every time we got a hotline work permit, what was the first operation?
Just one time cycle.
Oh, it was
It was one
time.
time
Yeah.
cycle. Yeah. What, and was that safe?
No.
No. So we had to put in what? Normal normal day-to-day service. When that breaker was an automatic, the first operation was time. When we called in, even with the fuse, and that is a fuse blowing scheme, even when we called in, the breaker went to what? First operation, what?
Instantaneous.
Right. We had that changed. So every time, even on this fuse blowing scheme, we got a hotline work permit, it gave us an I operation. So even on a fuse blowing scheme, the system, the breaker, is going to give you an I operation. So do you have to cancel your hotline work permit for both a fuse saving and fuse blowing scheme?
Yeah.
Yes. Yes. Thank you very much. Good answers out there. Okay, so when you have a hotline, it must be surrendered before closing any fuse and a fuse saving and fuse blowing scheme. This is easily forgotten, guys, especially while you're going through the course of the work of the day, because you know you've got some safeguard going on there while you're doing your work. And it simply is, we're done with our work. I'm ready for you to close the fuse, and they just closed the fuse and they got a bad transformer and they had locked the entire feeder out because they were on a hotline work permit. Take your time. You know, ask, is the hotline work permit surrendered? Can I close this fuse? Then they will advise you either yes or no. Okay. What time are we holding here? 10:43. All right, let's get rid of that. Okay, so we've learned here, and our system as far as fuse saving and fuse blowing in those two situations, there are, and Professor B spoke about this before, there are time curves that are going on between the fuse and the breaker. That's what we call fuse coordination out there in the world, plus all the equipment that's on our system also. Now, we'll talk just a moment. What are the protective devices? So we talked about breakers. And we talked about fuses. We know what's going on there. What are some other distribution protective devices that we use out there?
The ACIs.
Distribution, that's transmission.
Regulators.
That's not a protective device. That just changes voltage.
Those reclosers.
Reclosers, okay. We also have
The GoAbs.
a GoAb's a switch. It's not a protective device. All right, recloser, sectionalizer. All right, both the 3-phase and the 2-count, correct? That's pretty much it, isn't it? As far as distribution is concerned. Okay. Are we all happy with that?
Mm-hmm.
Okay. Fine and dandy. The more modern reclosers nowadays, guess what they have inside? You can actually get a hotline work permit on the reclosure that you're working at. That's going to be determined by the brand of reclosure and, of course, and all the features that it has on it. So if I have a breaker at a substation, and you know, reclosures are usually on long sections of line, and I come out of here and I've gone 10 miles, and I put a reclosure here, okay, and then I come out of here and I've got another 5 miles, then I've got we'll say an open point, and then we're going to go down here to another substation. This is like Conway to Loris. All right. If I'm working in this zone right here between the reclosure and the open point, do I need to get a hotline work permit on the breaker?
Yeah.
Okay, a reclosure gets its own hotline work permit.
Okay, no then.
Yeah, right. Reclosers, modern reclosers right here, have their own hotline work permit, and they function essentially the same, at least with the open and trip, as the breaker does. Okay, this one, as far as the fault occurrence, will recognize it first. It's going to give you an eye open. All right, it never had time to make it down to the breaker, and we're talking a long distance of line to make it to the breaker. So a fault occurs down here, you've got an eye, you've got a hotline work permit. You're not a fault occurs, it's going to open immediately. So what we discussed about before, you got to watch out for reclosures also while you're closing fuses down here anywhere in this section of the line on this circuit. You can get hotline work permits on just the reclosure itself. How about a sectionalizer? Three-phase. What does a three-phase sectionalizer do? Does anybody remember?
Opens all three phases
At one time, how many occurrences?
once.
Once. There you go. Okay. Sectionalizers, all right, don't reclose to start with. You've got one instance, especially on a three-phase one. One instance is you're going to see a fault, and it's going to open. All right. So do I need to get a hotline work permit? We'll change this to an S on this circuit. Do I need to get a hotline work permit on the breaker if I've got a sectionalizer working in here?
No.
No. Good answer. Okay. Now, here we go. 2-count sectionalizer. Here's my feeder circuit. I'm just going to put a switch here to designate it. Here's my 2-count. I'm working down in this area right here. Do I need to get a hotline work permit on this feeder circuit if I'm working beyond a 2-count?
Yes.
Why is that?
Because it's going to register the fault twice.
There you go. You're going to get an instantaneous open, and then what?
It's going to reclose
You're going to reclose. How many times?
twice.
Twice. That's why you need to get a hotline work permit on that circuit, because you're going to get an instantaneous reclose, and it's actually going to happen 2 times before the breaker eventually does what? Before the 2-count eventually does what?
And blows open.
Fires. Okay. I think we're pushing close to 11 o'clock here. It's 10:49. Let's meet back here at 11. Take your break, get your drink, do what you do.